It's the bits and pieces or the breadcrumbs that eventually allows hackers they only look for the hole in the cheese. They don't need the whole cheese. And I think that's the issue here. Who owns it? Who's in charge?
This is DevOps Paradox, episode number 146. Context means everything in security. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. It's 2022, and application security is a big waste of time. Right, Victor?
Depends for whom. I wouldn't say big waste of time, but it's the cause of depression and the cause of conflicts between different types of engineers.
Maybe a cause of fire drills as well?
If I would have to pinpoint a single group that everybody is in conflict with, that's always security. I mean, typically in big enterprises, people are in conflict with all the groups, kind of like everybody's at war with everybody. But, if there is one problematic group, not problematic, but one disliked, that's security. Nothing against security experts, right? And I think that's in big part because of the processes that companies established. And processes are usually, thou shall not pass. And I'm not going to tell you what you should do, but you shall not pass.
So to talk more about this today, we have a guest on with us. Actually, I think this is our first guest of 2022. We have Dean on from Oxeye. Dean, how are you doing today?
Fine. Thank you very much for having me here, Darren and Victor.
Dean, why don't you go ahead and introduce yourself, talk a little bit more about Oxeye, and then let's get into what your take on potentially application threats are in 2022.
Sure thing. So a quick intro about myself. I've been in the cybersecurity landscape for the past 18 years. Started my career in the R&D labs of companies like Checkpoint. Later on, moved up the ladder, moved to Imperva, to the application stack. And there I did some application security infrastructure. I would say I was part of the team that built the Imperva gateway and later on joined the Salesforce in the US. So I spent multiple years there. And in the last few years, I've had a consulting team where I've worked with government agencies in Israel, all focused on AppSec. So I've been doing that for quite a while. A year ago, I've started Oxeye with Ron Vider, my co-founder and CEO, where in Oxeye, our goal is eventually to help DevSecOps, application security, and developers to find and remediate code vulnerabilities in cloud-native applications. As cloud-native is the standard, applications are more complex, which means you need to not only find the vulnerabilities, but also provide context, understand whether specific vulnerability can be exploited from the internet or not. What are the infrastructure layers it depends on to provide better assessment and prioritization. And on the other hand, provide developers the ability to resolve these vulnerabilities by providing them what they were used to receive from static, dynamic, and interactive application security testing tools. So we find the vulnerabilities, assess them, and provide the developers clear remediation guidance, all with a very quick installation.
So you recently published a blog post on your site, which I'll link to in the show notes, about one scenario that you had. And can you give like a 30-second overview of what you found? And I will go ahead and sort of peel back the layers on it. Just because it's on the internet doesn't mean it's safe.
We were able to find an authentication bypass vulnerability in a major payment company by first looking into one of their Jaeger interfaces, which was open to the internet. And I think that's one of the challenges that we're going to talk about later on is because such an interface, a Jaeger interface that is open to the internet, expose a lot of data. And that data is the intelligence that can be later used to initiate or actually exploit the vulnerability. And that's the chain. We found the open Jaeger because the internal tracing were not encrypted. We were able to find access tokens and then use these access tokens for authentication bypass. And I think this chain of events is a good example for the threats that are, the modern threats of application security.
So if I understood right, it applies to those who expose Jaeger UI to outside world, right?
Our research was around Jaeger interfaces. There are many DevOps ecosystem tools that might be exposed to the internet.
It's almost curious, right, that it's not even directly related with vulnerability. Like, why would somebody make Jaeger public? I cannot imagine a single reason for that. And yet I know that is happening. Is it kind of simply, I don't care? It's completely internal tool, right, that applies and is used only by internal team in a company, right? There is no good reason why a customer or external user would see Jaeger, right?
I'll give 3 headlines to what you said, because I think each and every one of them is an optional discussion. The first one is security hygiene, understanding what tools are you using and understanding that you should apply security policies on them. Those are new tools, modern tools. That's one of the aspects. The other one is you need to make sure that the internal communication is also protected and encrypted, to make sure that even if someone passed the first gate, they are still locked in. They don't have anything to do with that. The third issue is who owns securing the ecosystem tools? Who's in charge? And that's the shared responsibility model, which is the third part.
So if people aren't even getting to that very first step about security hygiene, leaving a Jaeger UI setting out in the open on the internet.
It's actually more complex than what you just said. It's not leaving Jaeger exposed to internet. Jaeger by default is not exposed to internet. So you need to intentionally change Jaeger settings to make it accessible to public. It needs to be intentional action, right? It's not a default setting.
I agree with that, but one of the things that the blog post went into is that the Jaeger, and I've used this stack before, it was Jaeger and I think it was Zipkin. They provide a Docker Compose that is completely wide open. So I don't know if this financial services company or whoever, payment company used that complete stack or not, because I've used it before just for demos inside 4 walls. And as soon as I was done with it, I tore it down because I was done with the demo.
I think that's exactly the challenge here, because who's in charge of making sure? Because maybe someone had to change the default setup for a few minutes just to make sure that they have access because they needed to fix something. It's the bits and pieces or the breadcrumbs that eventually allows hackers they only look for the hole in the cheese. They don't need the whole cheese. And I think that's the issue here. Who owns it? Who's in charge?
What do you say? Who should own it?
So I think that's the rise of DevSecOps, because eventually there is the classic SecOps team who's in charge of the production, making sure that the production environment is secured. You have, on the other hand, the application security and the developers who make sure that the code is secured, the third part, the code that is written by the R&D, the third-party packages. But you also have what we call DevSecOps, and they need to make sure that everything else, that all the DevOps systems are secured. And you can throw in CI/CD security, who is in charge of making sure that the CI/CD process is secured. All the DevOps interfaces. In some places, people may come up and say it's the people who own the SaaS security, because you can treat Jaeger as another SaaS service, but I don't see it that way. I think eventually that's the role of the DevSecOps.
And how do you do that? I guess that the answer is not DevSecOps people will review every single pull request.
There's a sentence saying it's all about the people. Eventually, I think it's a lot of education, and that's shared responsibility. Make everyone understand. I would say it's like adding documentation to your code. It's part of the job and it's part of the responsibility. And you need to have security champions within the organization, within the dev teams, the DevOps teams. It's not easy. It's like a tax on the development. Like always, security has always been a tax, but it must be with the developers, with education, with security champions, part of the role.
So if I understand right, part of role of security would in that context be more education than anything else. Is that what you're saying? If it's shared responsibility, right?
I don't think a team of security experts on their own can, secure the whole process. They must have the developers on their side, and they must work together. And on the other hand, by the way, developers' role is not security. We all understand that. It's culture. It's not the classic technical discussion, I think. It's more for culture, education, collaboration. I think one of the focus of the modern security tools should be enabling such collaboration.
That's interesting. How does that look like, enabling? I know the traditional, let's say, or typical tools that tell you, hey, you have 57,000 vulnerabilities in your system, open a window and jump, because that's the only action you can do. How does that translate to what you just said? How do the tools enable that shared responsibility?
First, I would say it's a very good question. I think that the first step is not throwing everything on the security. I think that engineering leadership and mid leadership and and executive should be part of this ownership. And what do I mean by that is that it's not that you throw 10,000 vulnerabilities on the security teams, but you split these vulnerabilities between the R&D teams. And when you have a security champion within the team, he understands who owns each vulnerability, and I'll give additional perspective on that. Before that, we as security vendors must provide more accurate results. It's, the game of false positive and false negative, we must change it. We must add more data to the vulnerabilities that we find. We must improve the process, the analysis, make it more efficient and more accurate. And I think that's the first step, because I've been a developer. The first thing that you do when you find such a report is find the 3 false positives in it and say to the security team, that's not my fault. And I think that's the first step. I think after that, it's shared responsibility of leaderships, of engineering leadership and security leadership, to create a culture of embracing security by mid-management. Team leaders must own or understand that the vulnerability in their code contradicts their KPI. And they should be measured on that, but again, from a place of responsibility, not obligation. And it's hard. It's not an easy task.
Yeah, I have 2 comments on that. The shared responsibility that you mentioned, not shared, false positive, That means that tools probably need to start being a bit more intelligent than simply scan for all the vulnerabilities, right? Somehow to give you the list of vulnerabilities that apply to you, that are relevant for the context. And also, I feel like one thing missing is tools helping us, let's say, or telling us what to do in a way. I feel it's not enough to say there is a vulnerability XYZ, but that we need, hey, there is this vulnerability. I know that your code is stored in this Git repository. I know that you are using, let's say, Terraform. Here are the 2 lines you need to add to Terraform. Or this is the line that kind of pinpoint to the problem and present a solution. Now, I mentioned Terraform. It could be anything, right? But somehow, I feel like from the perspective of a developer, what I would be very happy to actually fix all the vulnerabilities if somebody would tell me how. And I cannot expect a security expert to tell me how, because it's 1 against 1,000 of us, right? So kind of human cannot do that. That would be too overwhelming in a way.
I'll respond in 2 sides. First, the analysis, then the remediation. In the analysis, I completely agree. And by the way, that's one of our main motivation within Oxeye. It's not enough just to scan your code. You need to add context. You need to understand what's going on in the surrounding components, microservices, infrastructure layers. You need to gather as much data as you can from the environment. And doing that during dev is not enough. You must see runtime environment to do better assessment and allow focus. So that would be the answer to your first comment, which is I completely agree. Tools must be more efficient and rely on context because there's a huge amount of potential vulnerabilities, but we need to focus on the exploitable ones, the ones that are currently in risk.
I would only add they're exploitable and fixable. I'm pretty sure that there are sometimes vulnerabilities that you say, yeah, there is nothing I can do about it, right? I know it sounds pessimistic on my side, but there are those cases as well, right?
In that case, I would expect the WAF solutions or the active protection solutions to jump in or the security to work with them to secure. But let's go back to the auto remediation. So I would say that in some places, it's easier than in others. When it comes to upgrading a package or upgrading a library, sometimes it's easier. But the problem with code is like, I would compare it to writing a Word document. You let the auto spelling to fix your spelling. You won't let it fix your logic because it's very hard to automatically change the logic of the code. And I think from that reason, our goal as security personnel or security vendors is to provide the developers the maximum amount of data that will help them to resolve the issue. That's what we do at Oxeye. So, that's what we are aiming for. It's not enough to give them a line in the code, and it's not enough to give them steps for reproduction. You need to treat a security issue like developers treat a standard issue. They want to see the stack trace. They want to understand what components are involved, how to reproduce, what is the common practice for fixing such vulnerability, and to also provide them the training to make them ready. And for that you have great companies like Secure Code Warrior and other security training companies, and it should be part of the education. So I think that's how.
So in building out context, we're talking about analysis versus remediation versus auto remediation. There are tools, if we're just trying to, let's say, upgrade a version of a library. I'm not going to name any names just because we're not going to throw anybody under the bus, but something like Dependabot, Resonate, I believe it's Resonate. Those kinds of tools give you the ability to sort of at least get a PR so then you can merge things in. But all of these things lead back to a hot topic around the software bill of materials. And it seems like that's just one of the starting places that you have to be at today, is actually producing a good bill of materials.
I completely agree. SBOM is one of the, hottest issues in understanding, what are the building blocks of your software. I would say that SBOM is the cheese. To understand the holes in the cheese, this is where you need the context. Because, if let's take, for example, the most common word in the AppSec in the last month, Log4j. Understanding that you have tens or hundreds of instances of Log4j, it's for granted. You know that. But where do you start? Which Log4j instance do you upgrade first? On which one do you spend the weekend? And which one can be postponed to the week after? And I think SBOM it's a mandatory requirement. As an organization that builds software, you need to understand what you're using. So it will be easier for you to mark any vulnerable packages of software or softwares that you're using. But the context jump in when you need to prioritize, what do you fix first? We have a never-ending softwares. Those softwares evolve on a daily basis, and they change on a daily basis. And a vulnerability that was malicious yesterday, today maybe this code is not in use, or tomorrow it will be used in a different way. And the game here is, as way I see it, is to understand the context of each package and understand whether it is currently exploitable.
How would you even figure out if something is exploitable? I mean, that seems like an almost impossible task.
So I think that if you analyze a running environment, a running application, today, because of, by the way, cloud native although it introduced many challenges, it also introduced many advantages. And for example, when you have the capability for application tracing, and you can see how the application works and which component is communicating with which component, you can understand in a high level of confidence whether a component is currently executed or not. And if it's not executed, if it's a process that is not being used in production, then there may be vulnerable code there, but the priority is lower. It's a potential vulnerability, but it's not there right now. On the other hand, if you have a running piece of code that you know that is vulnerable and you know that it is accessible from the internet and you can see the flow, then yes, that's what you should fix. And let's say a container, you have a misconfigured container that is currently in multiple instances, all used in production. That container, let's say that the access privileges of that container are high. That must be fixed. You can't take a snapshot and based on that, do the assessment. It's a continuous process. You always need to know your posture and based on that, prioritize.
I'm just glad you just didn't say continuous application security, because I think I would have just sort of jumped out of my first story window if you would have said that. Because I think a lot of times people will just say, okay, it's the tool will take care of us. That's not true. The tool can help us. Again, getting context, the way you just laid it out. If you don't have application tracing today, you're sort of up the creek because you don't have the data to make you don't have enough data to make the most correct decision. You probably have some data if you do have a bill of materials. If you've got your POM XMLs, if you're a Maven person, you can at least scrape those, aggregate them, and figure out, okay, do I have said numbers? But what's better than that is how is the code actually running?
I'll add another layer for that. If you can also fetch the WAF rules, then you have another piece of data because you know how the WAF is configured. And then even if you found a vulnerability, maybe right now it's protected by the WAF. The more data points that you have, like you said, you have the ability to make a thoughtful decision. And I think the game here is from how many resources you can fetch and how do you correlate the data in the best possible manner.
If I understood right, that also means that security might request or dictate usage of tools that are not necessarily directly related with security, like tracing, monitoring, and what's not necessarily strictly in domain of security, but are required for security tools to provide the needed context, right? Because what you were talking about, whether this is used or no, you need some kind of tracing, you need some kind of telemetry to exist in the system so that security-related tooling can provide the context that is needed, right? If I understood right, we're not talking only about security tools anymore living in isolation in a way, right?
I would say that security vendors must embrace application tracing, for example. And again, I'll give Oxeye as an example. When you deploy Oxeye, you receive OpenTelemetry transparently because we are doing an internal work to make sure that when you deploy Oxeye, you get OpenTelemetry immediately with no additional configuration, no additional settings, everything. It's my goal, it's my responsibility as a security vendor to make the results more accurate. If I choose to leverage application tracing tools, that's my decision. I think that cloud native architecture opens a field of capabilities that security vendors can leverage to provide better assessment. And I think it's on the security vendors to do that. I'll give another note. If as a security vendor, I'll talk to a customer and tell them, you need also to install A and B and C and D, they will say, okay, so you didn't give me a solution, you gave me a list of problems. So I think, again, it brings more responsibility on security vendors. And that's why we need to do that leap. And I think that many companies are doing that. And again, Oxeye is doing it in our, application security testing landscape, moving to the cloud native era.
I guess that's where we are getting a lot of help from actually standards, right? You mentioned OpenTelemetry. I guess it would be impossible for you as a vendor to hook. I mean, sometimes you can install some telemetry tool. Very often you will get to a company that already uses something and it's impossible for you to integrate with everything. Every telemetry collection tool. But then we have OpenTelemetry, right? And which makes it almost irrelevant for you which tools I'm using within telemetry space, because you know that the API is going to be the same.
I think that standards are similar to API. They allow everyone to play better. And, they set the ground for collaboration. And, eventually it makes everyone's lives easier. And so I completely agree with you. I think it's very important.
So as we're going through 2022, what do you think some of the other threats are going to be coming at us? One of the things I was thinking about is, and I don't know if this is true or not, but again, context. If a team doesn't have their own red team internally, the internet is their red team. So whether you think you have a red team or not, you do. Does it go beyond that? I'm sure it does.
First, I agree with you. By the way, a red team is, I would say, a tough hire. It's very hard to recruit a strong red team. It's a unique capability, and that's why you can't trust the ability to recruit a red team. I think you should be up to date. I think that's one of the roles of research teams within security vendors. Research team within security vendors and companies that vulnerabilities were found on their perimeter much play nicer, because what we found, will allow that we found an open Jaeger interface. That PR helped a lot of companies to see that and understand if they have an open Jaeger or not. So I think it's one of the roles of the research teams. Security company research teams, like Orca recently discovered a breaking formation and superglue vulnerabilities on AWS, and Wiz found on OMI Guard and Chaos DB. Finding vulnerabilities by research team and publishing them is making a huge contribution, because it allows better security for smaller companies that doesn't have the resources for the red team. And by the way, huge congrats on that, to HackerOne and all these platforms that allow that collaboration and disclosures, because I think it's a game, again, that everyone enjoy, and it makes the world safer. So I think that's one of the things that I enjoy seeing, sharing vulnerabilities that were found by both vendors and security teams.
What do you think is also going to happen in 2022? Are all the script kiddies going to go to bed now and just never wake up again?
No, they won't. I think it will keep being a challenge, because eventually what's going on is the digital transformation, the shift to cloud native, the growth in development of software is expanding the attack surface. The attack surface is getting wider. You have more layers. In the past, we had servers and code. Today, we have microservices, we have containers, we have clusters, and we have the cloud infrastructure. So the attack landscape will get wider. I think that the supply chain will keep being a challenge. There's no doubt about it. It's an ongoing issue. I think that the combination of application security, code security, and infrastructure security is also on the rise, because if you can enter the organization through an open container, jump up to the application, and from there do your reconnaissance, or you can enter the application from the microservice, go down to the container, and from there doing the reconnaissance, then this combination of infrastructure and application is a major threat.
So what can people do today? Let's say they don't have budget for red team. They know enough to figure out, okay, I do need to upgrade my files just because I know this version is susceptible to a vulnerability. What else can they do today? What should they be doing today?
So I think that in the case of no budget, I would completely go on open source tools and the free tiers of solutions, because they give a good sense of the status. It's the first step towards security posture. Sometimes people are afraid to see what's going on in their systems, because they may see that they're exposed. But I think that's the first step, to understand that security is another risk that must be managed. And if it's not a commercial tool, because there's no budget, then it should be an open source tool. There are many very good open source tools for the infrastructure, for the application, for permission. Of course, SBOM is the list of what you have. So it's another first step. Understand what you have and start protecting it with pigeon steps. You don't need to buy the strongest tool or platform out there.
So we've gone through all the security things. We know we need context. We know people, if they're not even doing the basics of security scanning, they need to do that. If they don't have a WAF, a web application framework, laying out in front of their application, they probably need that, especially if it's exposed to the internet. Heck, even if it's not exposed to the internet, even if it's inside your four walls, you probably still need it because, again, that was one of your earlier headlines, was the internal communications should always be encrypted. So if it's got to be encrypted, I mean, if you're running open HTTP versus HTTPS, you're at risk. If you're running FTP internally instead of SFTP, you're at risk. Even from good actors, bad actors, actors that just happen to show up one day inside your four walls. So do the basics.
I would add a small comment. Assume there are no four walls. In today's distributed environments, where you have so many moving pieces, I think the best assumption would be assume you have no walls.
Yeah, I agree that there's not four walls, but really there's billions of walls. So therefore there is no wall because of remote work. Not everybody is back to the office yet. So guess what? They're on VPNs. They are on basically just public sites, sometimes even without a VPN. I mean, obviously, most people are probably on VPNs, but if a company was more remote anyway to begin with, you're probably not always on VPN. So yeah, you're right. It's not four walls. So is it just the security posture of assume everything is vulnerable, so therefore just don't even connect up to the internet anymore? Is that what you're saying?
No, I would say that, if we take working from home, then, the zero trust approach that you can read about in Google paper or Beyond Corp from many years ago, they already wrote about it. I think it's not 10 years ago, but I think it's 5 or 6 years ago. It's a great paper to read, which the whole zero trust approach started from. Then it regards more to, to accessing the perimeter. When it comes to the application and the production infrastructure, I think eventually the assumptions should be similar. The solution is different. And I think you should treat each problem with its own solution and just understand that you have many, many moving pieces and security issues will rise and drop, and you need to be elastic enough to overcome the challenges and be ready for them.
All of Dean's contact information will be down in the show notes. And Dean, why don't you take just a moment here and explain what Oxeye is and how it can help out our listeners?
Sure. As I said in the beginning, Oxeye helps AppSec, DevSecOps, and developers to find and remediate code vulnerabilities in cloud-native applications. Oxeye application security testing platform find and analyzes vulnerabilities across the microservices and also analyze the different infrastructure layers. On the vulnerabilities that were found, Oxeye executes contextual risk assessment and active validation to point out the exploitable vulnerabilities. Once we've found these vulnerabilities, we then provide the developers clear remediation guidance in the form of stack trace, the exact line in the code, how to reproduce the problem, and the full application flow. And all of that is done with a quick installation, with no code changes, a very agentless approach. And in the bottom line, I would say that, many security categories have shifted to the cloud native. Application security testing has not, and that's exactly what Oxeye is aiming for.
Okay, cool. So Dean, thanks for joining us today.
Thank you very much, Darren and Victor. I enjoyed it very much.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. that helps other people discover this podcast. Go sign up right now at DevOpsParadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.